Hi guys, it's Mrs. Kerr. I'm going to be reviewing with you guys today higher degree polynomial graphs. So the first thing we need to remember when we're trying to graph higher degree polynomials is how the end behavior works. First of all, end behavior is what the graph does at the ends. In other words, at the beginning and the end. How does it start and how does it end? If you may remember, end behavior is determined by the degree, which is the highest exponent of the polynomial, and the leading coefficient. In other words, the number out front. So right here is kind of a little flow chart just as a refresher of how it works. So the first thing you have to decide is if the degree is even or odd. And what I always say to remember is if the degree is even, the end behaviors go the same direction. If they're odd, they go in opposite directions. So if the degree is even and the leading coefficient is positive, the end behavior is up, up. If the leading coefficient is negative, it's down, down. The suggestion I always gave for all the even degree ones is think of parabolas or quadratics, because that's an even degree and you already know what they look like. If the a is positive in a quadratic, it's up, up. If it's negative, it's down, down. Then if the degree is odd, they go opposite directions. So if the leading coefficient is positive, it starts down and it ends up. And if it's negative, it starts up and ends down. For the odd degree ones, you could always think of a line, because a line is technically an odd degree. A line with a positive slope starts down and ends up. A line with a negative slope starts up and ends down. Okay. So what we're going to do is be able to sketch a graph of the following. The first one I'm giving to you is in factored form. So if you remember in the prior lesson, we talked about the connection between the factors and the zeros or x-intercepts. So the first thing I know in this one is where my x-intercepts are going to be. Since x plus 2 is a factor, I know that there's an x-intercept at negative 2. Since x minus 1 is a factor, I know there's an x-intercept at 1. And since x plus 3 is a factor, I know there's an x-intercept at negative 3. Okay, so that we know from the factors. The other things we have to account for are the end behavior and the y-intercept. So the degree of this polynomial, you might look at it and say the degree is 2 because that's the highest exponent you see. But remember, degree comes from assuming we had multiplied this whole thing out and written it in the normal form. So I have two x's here, an x here, and an x here. So if I multiplied all those together, this would actually be degree 4. So if this is degree 4, if we go to the flow chart, that's an even degree. My a, okay, so if there's no number out front, we're just going to assume that's an invisible 1, so my a is positive. So I have an even degree, and the leading coefficient is positive, so the end behavior is up, up. So it's degree 4, and it's positive, so we know it's going to be up, up. So it's going to start up, and it's going to end up. The other thing I want to pay attention to here is this x plus 2 is squared. So there's an x-intercept at negative 2, but you may remember if it has an exponent on it, it doesn't just go straight through it like we're used to seeing. Since it's squared, this is going to be a bounce. Okay, so we know at negative 2 right here, there's going to be a bounce. So we know the end behavior, we know the x-intercepts. The only other thing we could find is the y-intercept as another point to graph. So to get the y-intercept, all we would have to do is plug in 0 for x, because anything along the y-axis, x is 0. So if I plug in 0 for x, this would turn into 2 squared, which is 4, times negative 1, which would be negative 4, times 3, which is negative 12. So the y-intercept is at 0, negative 12. Okay, so all you have to do is plug in 0 for x. So I'm just going to stick the y-intercept down there. I'm not going to draw the y-axis to scale. We just know it's going to be down there. So I'm just going to place it down there. And then I'm going to go ahead and do the sketch. So we know the end behavior is up, up. So it's going to start up. Okay, so first it's going to go through this guy at negative 3. Okay, and then remember, when we get to this negative 2, 1, it's a bounce. So at some point it's going to turn directions. We're just doing a sketch. So it doesn't matter how far down you make this go. It's going to do a bounce. Okay, so a bounce, remember, it just kind of bounces off, touches it, and comes back. Then it's going to have to go through this y-intercept down here. And then it's going to have to change directions and go through here. Okay, and you notice this jives with what we said. It's up, up. Okay, so that's kind of how you can do a sketch. We're going to do one more where we do a sketch. So this one says sketch a graph of the following. Again, this one is in factored form, so we know where our x-intercepts are going to be. So our x-intercepts, I'm going to go ahead and write them out for this one. Since x minus 3 is a factor, we know there's an x-intercept at 3. Since x plus 1 is a factor, we know there's a 1 at negative 1, and it's, again, a bounce. We know it's a bounce because it's squared. Since x minus 1 is a factor, we know there's 1 at 1. And since x plus 2 is a factor, we know there's 1 at negative 2. So those are my x-intercepts. So I'm going to go ahead and add those to my graph to start with. So I've got 3, negative 1, 1, and negative 2. Now I'm going to go ahead and determine the end behavior. So the degree of this guy, remember, again, be the highest exponent if you multiplied it out. So in this case, I'm just going to count up how many x's I've got. I've got 1, 2, 3, 4, 5. So this is a degree of 5. The a right here is a negative 1. So it has an odd degree, and the a is negative. So going back to our flow chart, odd degree, a is negative. We know the end behavior is up, down. So it's up, down. So it's going to start up, and it's going to end down. And then the only other thing I need to account for is the y-intercept. Okay, and again, for the y-intercept, just plug in 0 for x. So it basically just winds up being all the numbers multiplied together. So this would be negative 3, and this would be 1 squared. 1 squared is 1. So negative 3 times 1 is negative 3, times negative 1 is 3, times 2 is 6. So I know my y-intercept is at 0, 6. And again, I'm just going to put it there, not going to draw it to scale. Okay, you can if you want to since it's a small number. But so now that I've got my x-intercepts, my y-intercepts, my end behavior, accounting for the bounces, I'm going to go ahead and sketch my graph. So it's going to start up. Okay, it's going to go through negative 2. Okay, that's a normal one. And then negative 1, that's where the bounce is. So when I get to negative 1, it's going to bounce off of that. Okay, so you can see right here, okay, I'm kind of catching my error, and maybe some of you guys are too. The y-intercept's actually at negative 6. So I multiplied all of these together to get 6, but then I forgot about the fact that there's a negative out front. So I'm just going to go ahead and change that. And you can see it wouldn't really make sense otherwise. If this is a bounce, how's it going to then go off of that point there? So my y-intercept's down here. Now it's going to go through the y-intercept. Then these two are just normal, so it's going to go through this guy. Some point it's going to turn directions, go through that guy. So you can see that would be the final graph there. Okay, now we're going to do one more example, just working backwards. So this time, if we have a graph, writing an equation. Okay, and we're just going to stick with writing the equation in factored form. So the first thing I'm going to do is figure out where the x-intercepts are. So my x-intercepts here are at negative 3, 2, and 3. And none of them are bounces or anything weird, so they're all just normal. Okay, so I know my x-intercepts, so I can then determine my factors. This is degree 3, because there's 3 x-intercepts. And then if we look at our end behavior, it starts down and it ends up. So if it starts down and ends up, that means my a is going to be a positive. You can see the y-intercept is not labeled here, so as long as I make my a positive, I will be good. So I know in my factored form, I'm just going to make my a be a positive 1. And then since negative 3 is an x-intercept, one of my factors is x plus 3. Since 2 is an x-intercept, one of my factors is x minus 2. Since 3 is an x-intercept, one of my factors is x minus 3. Okay. And again, your a is just an invisible 1 you can stick there. So if you're given a graph, you can also work backwards and write the equation. And that would just be based off the x-intercepts and then the end behavior to determine if the a is positive or negative. So, okay, so that was just a quick review for you guys of the graphs of higher degree polynomials. I'll talk to you again soon.